G'day and welcome to the video on product functions. So I believe that this is exercise 4.4 in your textbook. I suggest that you go and watch the video on addition of ordinances or the sum of two graphs before you watch this one, because that one's probably a little bit easier to understand, and this one sort of is a similar idea, but it's a little bit more complicated. So unlike in the previous video where we added two graphs together, this time we're actually going to multiply two graphs together. That's what product means, multiplication. So rather than doing f of x plus g of x, we're going to do f of x times g of x. But the domain of the new graph is still the same as the domain in the addition of ordinances. It's the intersection of the domain of f of x and g of x. So wherever these two exist, then the new graph will, that's where that will exist. I'll show you that in just a second. Again, there's a couple of rules that I go by to try and help me understand what to do with this. And because we're now multiplying y values together, the same x values, but we're multiplying the y values together, anytime that there's an x-intercept on either graph, f of x or g of x, where that y value is essentially 0. And when I multiply anything by 0, on my new graph, I will get the y value of 0 as well. I'll show you that later. And if f of x, the y value on both of the graphs is either both positive or both negative, then on the new graph, both of the y value will be greater than 0. I just want to make that a little bit clearer. And I don't think I've been able to do that at all. Anyway, we'll just leave it like that. So if f of x, the y values on both of the graphs are both positive, then the new graph will be positive. But if they're also both negative, then the new graph will be positive, because negative times a negative is a positive. However, if one of the y values is positive and one of the y values is negative, well then the new graph will be negative, because a negative times a positive is a negative. And what we do is we just simply multiply the y values at each x point together. Now again, they're not really after this to be an exact science. They just want you to kind of understand what's going on. And again, probably the key point in all of this is they're actually after the domain. Do you understand how what the domain of the new graph is? But let's have a look at an example. So here I've got x multiplied by log x. I've drawn both of them on the graph. That's x there, y equals x, and this is y equals log x, and there's an asymptote at x equals 0. So if I think about the domain of the new graph, well, f of x, g of x, which I'll call log x, or the log x, that didn't have any x values below 0. In fact, it didn't even exist at 0 either. Which means for the new graph, we can't have anything to the left of the y-axis. You can't have anything less than 0. Now, the other graph, it didn't matter, that was unrestricted, but the new graph, therefore, has to be a combination of both of those, which is greater than 0. Now, I need to have a think about x-intercepts. This x-intercept is not going to matter because that's not included on my new graph anyway, but this x-intercept matters. That's when x is 1, y is 0. So that means that because my y is 0, I'm going to do 0 multiplied by that point there is actually 1, 1. 0 multiplied by 1 is always going to be 0. So on my new graph, I'll go down a little bit, on my new graph, it's going to go through that same point of 1, 0. Now, when x is less than 1 for the log graph, I've got a negative x value, and I've got a negative y value and a positive y value between 0 and 1 for x. So when I've got a positive number multiplied by a negative number, the answer is going to be negative. Again, I'm not really sure how negative it is, like how far down it is. I just know that this part here between 0 and 1 has to be below the x-axis. There's an asymptote at x equals 0. Now, when x is greater than 1, both of the y values are positive. So therefore, a positive number times a positive number, it's going to do something like that. I'm not sure if that's exactly what the graph looks like, but essentially I've got the key points of the 0 and I've got the positive and the negative. Let's just have a look at another example just here. So this is when I've got x squared multiplied by e to the power of x. I draw them both. They're both actually, both of their graphs exist at all times, because the domain of x squared is all real numbers and the domain of e to the x is all real numbers as well. So both of them, there's no restriction on the domain is all real numbers. My x-intercepts on this graph here, x squared, that's a y value of 0, so 0, 0. And this one will be a value of 0, 1. So 0 times 1 is going to be 0. And I'll pop down and see that. 0 times 0 is 1, that point there. After x is 0, they're all going to be positive answers because both of the the numbers are positive, and so it will just be a positive times a positive. It will just go through the roof, and it'll go through the roof fairly quickly actually, because a big positive times a big positive is an even bigger positive. The left-hand side is a little bit tricky. I know that there's an asymptote at y equals 0 because these numbers here keep going closer and closer and closer to 0. Now, I don't really care too much about this little lump here that you've seen. Like, I mean, I can do this on a calculator and recognize that it does that. I guess that, the points that I probably wanted to make here is that if you've got a small, what am I talking about, small x? I mean a small y. If you've got a really tiny y value and you multiply it by a big y value, this tiny y value, because it's an asymptote, because it's getting closer to 0, it's actually going to influence these y values here. So that's why the asymptote comes back in like that. But there will be a point where, like for example, it might be when x is a half and a half, it might go up to a quarter, and then it comes back down again to 0. So I guess I don't really want you to focus too much on this, but the point is that they're both positive on the left-hand side and they're both positive on the right-hand side of the y-axis, so they're both up there, and then the x-intercept as well. So hopefully that's given you a little bit of an idea as to how to draw these graphs. That doesn't have to be exact, but we're just after, do you understand some of these rules up here, and do you understand the domain? So thanks for watching. If you need any more help with it, please let me know.